Welcome again for the properties of S matrix for H-plane. Before this lecture, we have come to know about the E-plane matrix. Now we will go forward to know about the H-plane matrix. So the thing is that what is the H-plane T? H-plane T has the collinear port similar to the E-plane T, but for that rectangular waveguide, the port 3 is known as the side arm. Okay, and this H-plane T is also known as shunt tree. As you can see, it is on the side. It's not perpendicular to the collinear arms. It's almost lies on the side of the arm, so it's known as a shunt tree. As the axis of the side arm is parallel to the magnetic field, so it is known as the H arm, and it's also known as the current junction. As the magnetic field divides itself into arms, the cross-sectional details of H-plane T can be understood by the following figure. So that's the thing. That's the thing of the H-plane T junctions. Now, for the S parameter calculation for H-plane T. The S parameter calculation of H-plane T, the properties of H-plane T can be defined by its S3 by 3 matrix. So as you can see here, it's quite a bit parallel from the S13 and S23. So that is a 3 by 3 matrix from the equation 1. You can get it, and symmetric property will also carry, and the if the port will perfectly match it, we will get the S33 is equal to 0. That's quite similar. So the scattering coefficients 1, 3 and 2, 3 are equal here as the symmetrical in plane. If it is symmetrical in plane, so it will happen. But for 180 degree shift, we get in previous versions that 2, 3 port and 1, 3 port are 180 degree shift. So S23 is equal to minus S13 for E plane port. But for H plane T, there is no such a thing, such a condition for 180 degree shift. So this condition will not apply for 1, 3 and 2, 3 ports. Okay. Now just put the values that you can get from the previous conditions. Now the conditions apply. You have 4 unknowns with the considering the symmetry property. Again you get the same thing, same type of calculations for the unitary property. You can calculate some of the variables. Now just use the same calculation that stays for row column multiplication. Okay, same multiplication is there, and again from the equation 6 we get this type of calculation till the equation 9, and after that we have to just get the value from this S1222 to whatever else, and last of all we will get the equation right, and we will just put the value for the S matrix and find it similarly. And if you want to find out the input output relationship, we can use the input as A and the output as B to find out the H-plane T scattering properties. Thanks to all. So this is the discussion of H-plane T. Now what about the properties of S matrix for H-plane T2? So for the H-plane T, we will get 4 ports. Okay, how that we will get? Now I just look forward to this. This is the EH plane waveguide T, and it is formed by attaching 2 simple waveguides. If we attached both collinear arms with the E arm and H arm, so it is known as magic tree or hybrid tree or 3 dB coupler. The arms of rectangular waveguide make 2 ports called collinear ports. Here is port 1 and port 2. You can see here the collinear arms. The H arm is on the side, and for the E arm is on the perpendicular. So there is 2 ports for the parallel port and also the series port. Now the main thing came forward. Now the characteristics of EH plane T. So for EH plane T, you have to derive 4 ports. That means S4 by 4 will come into account. So the following figure shows the connection made by the side arms to the bidirectional waveguide from both parallel and serial ports. Here I have made some calculations to get understood, but the thing is that we should not write this. We just for the basic thought that how the wave really transfers, we can take any idea from that. If a signal of equal phase and magnitude is sent to port 1, port 2, then the output at port 4 is 0, and the output at port 3 will be the additive of both the 1 and 2. That means if a signal is equal phase and magnitude, so it will be sent to port 1 and port 2, then the output at port 4 is 0, and the output at port 3 will be the additive of both the ports 1 and 2. If a signal is sent to port 4 E arm, then the power is divided between port 1 and 2 equally but in opposite phase, while there will be no output at port 3. That means S34 is equal to 0. If a signal is fed at port 3, then the power is divided between port 1 and port 2 equally, while there would be no output at port 4, hence S43 is equal to 0. If a signal is fed at one of the collinear ports, then there appears no output at the other collinear port, as the E arm produces a phase delay and the H arm produces a phase advance. That means S12 is equal to 21 is equal to 0. Now that is the properties of EH plane T. The properties of EH plane T can be defined by its S4x4 matrix, as you can see here, the bigger 4x4 matrix. So there, as it has H plane T section, H23 is equal to S13. As it has E plane T section, it says 2 so minus 14. The E arm port and H arm port are so isolated that the other won't deliver an output if an input is applied at one of them. Hence, this can be noted as S34 and 4 is equal to 0. So there are some considerations right there for equation 2, equation 3 and equation 4. Why equation 2 came? It came because of the H plane T section, and for 180-degree shift, that means the fourth port is for the E plane, so you can write S24 is equal to minus S14. And for the E arm port and H arm port are so isolated, so it will not deliver any kind of output there. So 34 and 43 is equal to 0. And there is a symmetry property in all other matrices has the same thing, so we will get the same. That's ij is equal to ji 1 2 2 1 1 3 3 1 1 4 1, whatever else they might be, and S33 and S44 for perfectly matched condition, this junction will be 0, and after the putting the value you will get the equation 7. Now the same thing, the unitary property, that means the S matrix and its conjugate will be equal to an unit matrix, diagonal matrix, right? And after that, just put the value for just calculate the multiply the two S matrices and you get equation 8 9 10 and 11. Now similarly that you have done in the previous way, you can get the value from each S matrices and each elements. You will get the value, and just last of all just put the value there for perfectly matched conditions. So what are the applications of this? Is the condition, this is the last condition of the 4x4 matrix, or the H plane T, or the hybrid T, or the magic T. Now applications of the H plane T. H plane junction is used to measure the impedance. A null detector is connected to H arm port, while the microwave source is connected to the H arm port. The collinear ports together with these ports make a bridge, and the impedance measurement is done by balancing the bridge. H plane T is used as a duplexer. A duplexer is a circuit which works as both the transmitter and the receiver using a single antenna for both purposes. Port 1 and 2 are used as receiver and transmitter, where they are isolated and hence will not interfere in antenna in connected to E arm port. A matched load is connected to H arm port, which provides no reflections. Now there exists a transmission or reception without any problem. So H plane T is used as a mixer. E arm port is connected with antenna and H arm port is connected with local oscillator. Port 2 has a matched load which has no reflections, and port 1 has the mixer circuit which gets half of the signal power and half of the oscillator power to produce the IF frequency, that means intermediate frequency. Thanks all for the lectures.